In this lesson, we're going to look at how to count the subatomic particles in an atom. The three subatomic particles that make up an atom are the electrons, the protons, and the neutrons. Let's start with a review of these three subatomic particles in terms of their different properties, like their charge and their location. So the protons are positively charged, the electrons are negatively charged, and the neutrons have no charge. Okay, so on the side over here, we have a reference of the three particles. I'm also showing you the typical symbols that we use to represent these particles. Generally speaking, you'll see the electron more often than the other ones, but it is good to know to recognize them. Now, the relative mass is important here. Okay? This mass is in what's called atomic mass units, and we'll look at that more in detail when we look further at other parts of atomic structure. But for now, what you want to understand here is that this is a relative mass. So it's not saying it's not saying it's 1 gram or 0 grams. It's just saying that relative to each other, this is their mass. So if we think about that, if I had a little scale, like a little balance, if I put 1 proton on one side of the little scale here, then I would need 1 neutron on the other side in order for it to be balanced. Because they both have the same mass, okay, it will be balanced. When I think about electrons, so their relative mass is 0. Now that does not mean that they don't have a mass at all. It's just that their mass is so small relative to the proton and the neutron. So if I have 1 proton on the side of my scale here, in order to make this balanced, thinking about this like a little teeter-totter, if you're going to balance your teeter-totter, we would need to place 1,936 electrons on the other side. Okay, so you can see it takes a lot more electrons, so relatively speaking, they're very light, which is why we assign them a mass of 0, a relative mass of 0. Now, this will be important for our counting of protons, electrons, and neutrons. The other piece here that we need to kind of think about or remember is that the protons and the neutrons, those are in our nucleus, okay, in the center of the atom, and then the electrons are located in the electron cloud outside of the nucleus. And most, if not all of the mass, for our purposes, all of the mass is going to be made up of protons and neutrons. Okay, so you can think of an atom as having a very dense center, okay, with lots and lots of empty space around it. So how do we know how many of these protons, electrons, and neutrons there are in a given atom? We use the information that's given to us in the periodic table. The first thing that we'll do is we will look at what an atomic symbol looks like. So if I look at the periodic table for lithium, I can see that there is the atomic number of 3 and the atomic mass of 6.94. I have a bit more of a precise value here, but it's rounds to the same. So lithium has a mass number of 6.941 and an atomic number of 3. So when we write the symbol, we write just the element symbol, and then we write our mass number and our atomic number. Now, we're going to be addressing the fact that this is not a whole number in a couple of lessons when we're looking at isotopes. But for now, what you want to recognize is that you'll be given a specific lithium, okay? A specific isotope, it's called, of lithium. So a lithium of a particular mass instead of this rounded decimal average mass. So if I want to look at lithium 7, okay, this is what it's going to look like. And I want to look at a particular isotope in order to count my protons, electrons, and neutrons. How do I know that I've got a particular isotope? I've got whole numbers here. So let's use this rule that we've been given here to help us to count in lithium how many protons, electrons, and neutrons there are. My atomic number is my bottom number here. It is 3. And my atomic mass of lithium-7 is 7. Now, the number of protons I will know and get from the atomic number. The number of protons essentially gives me the identity of the element. So anything that has an atomic number of 3 or has 3 protons is lithium. Okay, so the number of protons that we have in lithium is 3. Now, the next thing that I'll do here is look at the electrons. So once I know how many protons I have, then I can also determine the number of electrons. And we're working with an atom. So there's no charge here. Okay? It's not an ion like lithium plus. If there's no superscript here with a plus or minus charge, then it is a neutral atom. It has no charge. So the number of protons has to equal the number of electrons in order to make sure that the charge is 0. Now the last piece is the number of neutrons. So we mentioned earlier that the atomic mass is really the protons and the neutrons that are contributing to it, right? The electrons don't really contribute to the atomic mass because they are so light relative to the protons and the neutrons. So when we look at the atomic mass, what is useful to us is that the atomic mass is equal to the number of protons plus the number of neutrons. Okay. Why does that work out? Because they essentially have an equal mass. And this mass here is in the same unit as the protons and the neutrons. So in lithium, if I have 3 protons and a mass of 7, I can find the number of neutrons by taking my mass number and subtracting my atomic number. 7 minus 3 is 4. And when you look at the way that we've set up the symbol here, it's naturally giving us the 7 minus 3 is equal to 4. So let's look at sulfur 32. Find sulfur on the periodic table. It's giving me the mass number. Okay, my sulfur is here. So the average atomic mass is 32.07, but the isotope we're working with is sulfur 32. And then I'm going to identify that it's got a atomic number of 16. So if I start over here, I've got a mass number of 32, atomic number of 16. To count the number of protons, that's the atomic number. The number of electrons is the same because it's a neutral atom. And then I find the difference, 32 minus 16 is equal to 16. Now you might find that you're wondering for the first, 20 elements in the periodic table, it is often the case that the number of protons and the number of neutrons is equal to each other. It's not always the case, so make sure that you are going through the process. The larger the atoms and the more radioactive they are, the bigger the difference there will be in the number of protons and neutrons in an atom.